Hello guys, welcome back to my channel. This is Mallikarjun. Right, so what I'm going to do in this particular today's demonstration, I'm going to briefly explain about um, how the rack to rack database restore and recovery scenario works. Along with that, how the rack to rack RMAN duplicate, RMAN clone scenario works, and what's the difference between this restore and recover and then RMAN clone when it comes to rack database cloning. Considering I have a source cluster and then I have a target cluster. Source cluster might be 2 node, 3 node, 4 node, and target cluster might be again 2 node, 3 node, 4 node, whatever it is. Whatever, like, it doesn't matter. It's a rack to rack cloning, rack database cloning from rack environment to rack environment, right? So quickly I can get my the image here, which talks about more about restore and recover versus clone scenario. With that, once we start that brief explanation, and then we'll go over entire run log, and then we'll go over entire lab, and then we'll see the demonstration on that. Right. So if you're new to my channel, and then if you missed out my previous videos, always go back to YouTube and search for Malik034, and then please do subscribe my channel and then watch my previous videos. I detailed explained about RAC database restore and recover, how it works, and then I given a lab demonstration on that. How the rack to rack RMAN duplicate or RMAN clone works. Again, I have taken one more demonstration on that. So please go ahead and watch them. And then if you like my videos, please don't forget to give thumbs up and share with your friends and colleagues. Right. Having said that, let's go back to that image. Right. So this is my server A. That is my rack cluster A. And then this is my rack cluster B. Assuming these two are the two rack cluster, we want to clone this DevDB from this rack cluster A to rack cluster B. And then how you're going to clone this one. There are different methods. How you're going to duplicate this database. There are different methods. We will use something called restore and recover. We'll take a backup of this DevDB and then we'll do a restore and recover on the target cluster. Or we can take a backup of this DevDB and then we can use the RMAN clone or RMAN duplicate method to clone this particular DevDB in that server B. When you use a restore and recover method, you don't have an option to change the DB name or the change the DB ID. If you're assuming that DevDB is the database name and then it has a DB ID 111, if you use a restore and recover method, you have no option to change that DB name or DB ID. Your DB name is going to be DevDB and then the DB ID is going to be same as 111. If you use this DevDB backup and then if you use the RMAN duplicate or RMAN clone, you have an option to change the database name. Like either you can go with the same as source database name, that's a DevDB, or you can give the new name, testDB or UATDB, any name you can provide over here. So what happens here? If you give a new name, your DB ID will get changed here. Even though DevDB, you can restore it as a DevDB using RMAN clone or RMAN duplicate, your DB ID will get changed. That's a unique ID will get assigned to that database. So that's the difference between your restore and recover. In restore and recover, you have a limitation. You don't have option to change the DB name and DB ID. Whereas in clone, you have option to change the database name, or you can go with the same database name, but any cost, your DB ID will get changed. That's the advantage of clone, RMAN clone or RMAN duplicate. So in case of restore and recover, you're going to connect as a RMAN target slash. In case of clone, you're going to connect as a RMAN auxiliary slash. And then we're going to restore or going to clone my database. So that's a quick intro about restore and recover versus clone, how it works, whether it's a standalone or rack to rack cloning or standalone to standalone cloning, doesn't matter. So the scenario or the explanation is going to be like same here. So if I take a real DB ID, this is my DB and it has a DB ID 806 ending with 806. When I did a restore and recover, it has restored with 806, same DB ID and same DB name. And when I clone this DB using RMAN clone or RMAN duplicate as a DB using RMAN auxiliary, so it got changed DB ID 397, right? So that's a quick intro about this restore versus recover versus RMAN clone. Right. So here, if I go on my run log here, rack to rack database restore versus recover, restore recover versus RMAN clone. I have pretty much 4 steps here. One is prepare a source database backup and then take that source database backup and transfer it to the target server. That's the very first step. And then the second step is we'll demonstrate on the restore and recover scenario. And the third step is we'll do RMAN clone. And then the post, that's the fourth step, that's the post clone activities. Right. So my first step is source database backup. Like, I can pretty much connect to RMAN target, run, allocate channel, and then backup as a backup set, database, archive log, and then control file backup, and then SP file backup, and then release the channel. This is my RMAN command to take my source database backup. Once I take my source database backup, I'm going to copy my source database backup to my target server. So if I quickly uh, explain about my source database here, Oracle Vara Node 1 and Vara Node 2 are the uh, two of my cluster databases. If I do dot .varanv devdb1 and then I'll set the Oracle home, and then I'll just set grep the environment. It's a devdb1 instance connected to my 19c Oracle home here. I can just connect RMAN target slash, and then I can just run that run block. Run allocate channel 1 backup as a backup set database. I'll take user on backup, full backup, archlog, and then I'll take user on backup archlog, backup current control file, user on backup control file, backup SP file, user on backup, and then release channel. This is my RMAN command prompt I'm going to run here. The moment I run that RMAN command prompt, it's going to start backing up my archlog. So my archlog sequence, if you observe here, it's going to take sequence from the thread 1, that's instance 1, sequence from thread 2, instance 1 and instance 2. It's going to take archlog backup from both the instances, instance 1 and instance 2, devdb1 and devdb2, because both are archlogs are going inside my Rico disk group. So that's a common shared disk group. So archlog getting generated over there. So it's going to take my archlog backup here. So you can see user on backup archlog. It has taken archlog backup, and then it has started with the data file backup u01. So this is your data devdb data file syssock system undo and user. It has taken my data file backup here, user on backup, full backup. And again, it is going to switch one archlog from thread 1 and thread 2, the 24 and 12. It has taken my archlog backup here. You can see this is my archlog backup. It has taken here. Right. Again, it has taken my control file backup here, user on backup control file. Again, it has taken my SP file backup here, user on backup SP file. It has taken your archlog data file, control file, and SP file. And then at the end, it has taken my auto backup, my SP file and control file auto backup. It has taken inside my record scope. So that is your pretty much source database backup. Once you take your source database backup, you can go to target and create this user and backup directory, do lsf and ltr, nothing is available here. On the source, again, user and backup, you can see all these 5 backup pieces here. And then you can do scp star that whatever available inside user and backup to target server. Once you copy that one, and then on the target, you can see all the files are copied here. So now we'll see the first scenario, that is restore and recover. So we have all the files available on the target server, and then we can use something SQL plus SSDB, and then we can start our instance in no mount using this dummy init file. This particular dummy init file, you can see that this is your dummy init file, init devdb.vara. So it has the DB name, your DB unique name, your cluster database equal to false. Whenever you are restoring your source RAC database to RAC database, you have to make sure that first you restore it as a standalone database. For that, you have to make your cluster database equal to false, and your audit file list, DB create file list, online log dest 1, dest 2, your data and reco. And then these two parameters, you no need to set it here, because you're restoring it as a devdb, and then you're restoring it as a devdb on the target server. So you no need to mention your DB file name convert and log file name convert, because your data devdb, you're not going to go with the test DB, you're going to go with the devdb only. So you no need to mention the DB file name convert and log file name convert. Just comment out these two parameters. And then your control file, one is under data, control 1, one is under reco, and then control 2. And then your DB file, your DB recovery file test size, and DB recovery file destination location, archive destination location. This is a simple P file, and you can start with that P file, SQL plus SSDB, startup no mount. So what I'm going to do is like SQL plus SSDB, startup no mount, that P file, whatever that init devdb. So it's going to start your instance here. Once it starts, you connect to RMAN. So the next step is here. Connect, once you start your instance here, this is the instance startup no mount, and then connect to RMAN, restore SP file from that SP file backup, restore control file from that control file backup, and then alter database mount. You do catalog starts with that user and backup, and then run, restore and recover, alter database, open reset log, and then your database will be in open mode. These are the pretty much 10 to 11 commands here. What I'll do, like I will connect to RMAN target slash, and then restore SP file. I'm going to restore my SP file from this backup, and then SP file is restored. You can verify that one here, and the DBS location it is restored. And then again connect back to your RMAN, and then restore control file from that control file backup. It will restore your data and reco, one control file and one control file here. One is under data and one is under reco. It has restored 2 control file here. You can do alter database mount, and then do catalog start with your user and backup. It's going to catalog your both control file and HP file here, which is available under user and backup. And then once the catalog is done, you can do run block, restore database, and record database. So the moment you do restore database service, it will take this full database backup set, and then it will restore all the data files, stock, system, undo, users, and all the data files will get restored here under your data disk group. Once the restore is done, and then it will start with the media recovery. You can see it started with the media recovery here. It's applying the media recovery here, and then you will get this particular error message: media recovery requesting for unknown archelog in the thread 1 sequence number 23. If I go up, when I take a backup on my source side, it has backed up to 22 archeologs. If we see here, like this is my backup information. It has backed up here up to my thread 1 23. It has backed up here, and then it has backed up my data files, and then later it has switched one archeolog, and then it has backed up my thread 1 sequence number 24. Sequence number 24 is the highest sequence number which has backed up in your backup piece. And then when you do restore and recover, it's trying to restore one extra archeolog, that's the 25th, and then you will get error message. You can see with the thread 1 sequence number 23. So this is requesting for this unknown archeolog number. It's of 23. If I go up one more time, which is on your thread 1 with the sequence number 23. If I scroll it up here on my backup piece, right? So this is my backup information here. It has backed up to thread 1 23, and then the whatever that unknown archeolog one, you can ignore that one. So we can ignore this media recovery, and then alter database open reset log. Your database will get opened here. So once your database will get opened here, and then you can see your dev DB, which is in read write mode, and then your RMAN clone scenario. You can see here. This is your database is opened in read write mode. You can ignore this one. You can just complete it with your restore and recover scenario. Now we are going to do RMAN clone scenario with the RMAN duplicate command. So for that, again, we'll use the same backup pieces. What we're going to do it here. Now we're going to just start with the init test DB. Init test DB is again one dummy file. I'm going to create it here. You can see cat that init test DB. Your DB name is test DB. Your DB nickname is test DB. Your cluster database equal to false. Same what we did for dev DB restore, because we're restoring it as a standalone database. And your audit file test, your DB create file test is data, and then online log dash 2 and log dash 2, dash 1 and dash 2 like data and reco. And these two parameters we commented when we were restoring the dev DB. Now we are going to enabling these two parameters: DB file name convert, log file name convert. What we're going to do it here, data dev DB, we're converting it as the data test DB. Log file name convert, whatever the data dev DB, we're converting as the data test DB. Reco dev DB, we're converting it as a reco test DB. So these two are mandatory here when you are renaming your database, or when your file system or data disk structure is different. You have to use this DB file name convert and log file name convert. And control file, you're going to use the data test DB control 1, reco test DB control 2. And then your DB recovery file destination size, DB recovery file destination, and your archeolog destination, use DB recovery file. This is a dummy P file what you created. And then we're going to start with that no mount using that P file and connect to RMAN auxiliary. You can see RMAN auxiliary, not RMAN target. And then duplicate target database to test DB using that backup location with a no file name check. No need to check the file name. Right. So let's see here .env, setting it to test DB, Oracle home, and then env grep ora test DB instance, Oracle base, Oracle home, SQL plus SSDBA, and then startup no mount using that P file. Your instance is started here. Connect to RMAN auxiliary, and then run this single command: duplicate target database to test DB, backup location. You're going to give that backup location. It's going to start restoring, cloning your database here, and then it has. You can see first it has do the shut down that instance, and then start up clone mount. It's going to shut down and start up clone mount. It will set the DB name as a dev DB. It will set it as a original database name first, and later it will recreate your control file, and then that time it will change the DB name and your DB unique name test DB, and then your prime clone restore your control file using this control file backup. It has restored your control file, set your DB name, DB unique name, and shut down your database and bounce it, and then restore your control file, data, reco, test DB, and control file 1 and control file 2. It has restored your control file here, and then database is mounted here. Once it is mounted, it is running your backup script here. Set new name for data file 1, 3, 4, 5, 7. It has renamed to plus data here. It has did a set new name, and then it has restored your all the data files here using this full backup. Use your own backup, full backup. And then after that, it has switched all the data files here. Once the data file switch is done, it is doing a recovery. It has applied all the archeologs here. Once the apply archeologs is done, it's going to do recreate your control file. It's going to set your DB name as a test DB, DB unique name as a test DB, and then it's going to recreate your control file here. It's going to recreate your control file here. When the control file is recreated, it will do switch data file, sysaux and system undo. It will do catalog all the data files, and then these are your catalog renamed data files. And alter database open reset log. It has opened your database with the reset log. Right, your database got opened and now it is in reset log mode. Like now your database DB is in read write mode. So that's a third step with the RMAN duplicate or RMAN clone step. Now what we're going to do, RMAN restore or clone post steps. What we're going to do in the post steps, we'll create a P file from the target environment, and then we'll modify that P file accordingly my target environment. And then we'll start using that modified P file. If I scroll down here, I just listed out my P file and P file from source. From the source DB, this is my P file information. You can see this is my P file information here from the source DB. And then this is my target on the DevDB. This is my DevDB P file here. Only thing is, when you're doing a DevDB to DevDB on the source and target, pretty much all the parameters are going to be same except this a local listener. Local listener, which is pointing to Oracle Node 1 and Oracle Node 2 here. And then on source, it will be like pointing to Vara Node 1 and Vara Node 2. That's the only difference in the when you're cloning, when you're doing a restore and recover from DevDB as a DevDB and the target server. And whereas if I go on the target server, if you're restoring it as test DB, you have to change all the parameters. Whatever the dev DB is pointing, you have to make it as a test DB, and then also your local listeners, you have to change it to test DB, and then undo table space, everything you have to make it as test DB. So I listed out here my target test DB P file and my target dev DB P file and my source dev DB P file. So all the three things I listed out here. Right, I'll scroll it up and then we'll do that post step activities now here. Right, this is the post step activities here. So what we're going to do it here, SQL plus SSDB, shut immediate. Whatever that we restore database, we're going to shut it down. And then we're going to create that init DevDB file with all the modified parameters according to the target. And then we'll start that as a init DevDB1. So we'll set the environment DevDB1, and then we're going to do startup SQL plus SSDB startup mount P file. We're going to start with that init DevDB1, which has modified with all the RAC parameters. And then what we're going to do, we're going to create one SP file inside data disk group, and then we'll shut it immediate. And then we'll create a init file, which is point to that SP file. Just you can cat init devdb1, which is just point to that SP file on node 1. Similarly, on node 2, cat that init devdb2.vara file, point to SP file location. And then just do SQL plus SSDB startup mount, show parameter SP file. It should show you SP file location. And then do shut immediate, and then convert your RAC DevDB as a RAC DevDB. SRUCTL add database, DevDB unique name, and then your Oracle home, and then your parameter file, and then your immediate shutdown immediate, and then data and record disk group. So this is your adding your database to cluster, and then adding your cluster instances. SRUCTL add instance -d DevDB instance 1, instance 2 on node 1 and node 2. And then do SRUCTL start your database. So these are your simple post clone step activity. You have to do it for your DevDB and testDB when you're using a restore and recover, or when you're using RMAN duplicate database. You have to use accordingly whatever the steps are needed here. So these are your post step logs here for DevDB. So we just did a PWD or INV. We set it to DevDB, and then we did a shut immediate, and then we just close this particular DevDB whatever has restored here. And then once that is restored, like we're gonna do that modify that init file. And then once you are modified that init file, we're gonna do vi init devdb.1 vara, and then we're gonna start that particular instance here. Like we're gonna shut down that whatever the restored devdb database. When the shutdown is done, we're gonna start set the environment to devdb1, and then we're gonna start with that particular init file. Startup mount P file, we're gonna init devdb.1, which has all the RAC parameter with the cluster parameter equal to true. And then we're going to create a P file. We're going to create a SP file inside your data disk group using that RAC modified RAC parameter file, which has like this particular init file has all the RAC parameters. And then file created, and you're going to shut down your database. Once your database is shut down, and then you're going to create init file in the node 1, which is point to your SP file. Whatever like cat you do init devdb.1 vara, it is pointing to SP file, which is inside data disk group. And then you're going to copying that init devdb1 on Oracle node, that is node 2 as init dev db2. So if I go on node 2 and go answer my db home dbs location, if I do cat that init dev db.ora, which is pointing to my sp file. And then now what I'll do, like src, like again set the environment back to your dev db1, and then you can do startup mount and then show parameter sp file. It will be like started with your sp file, which is inside your disk group, data disk group. And then you do shutdown immediate. And then if your database is shut down, you can add the database to cluster node using this command. src add database dev db oracle home, and then your parameter file, and your shutdown option is immediate data and record disk group. src add instance 1, src add instance 2, src config. You can see the database dev db oracle home, your sp file, and your role is primary, and then data and record disk groups, and then dev db1 dev db2 running under node 1 and node 2. And then you can do src status database, your dev db1 dev db2 not running on node 1, not running on node 2. You can see src start database dev db, src status database. You can see dev db1 running on node 1, dev db2 running on node 2. Right, so that's a pretty much post steps for your dev db. And then post step for your test dbs are going to be like similarly whatever we did. Test db1 test db, and then connect to sql plus sdba, and then do shut immediate. And then you can do vi that init test db.1 vora, which you have to modify all the test db parameters from the source. So you have to get that source parameter file and then modify accordingly the test db, and then set the environment to test db1. Once you set the environment to test db1 instance, and then sql plus sdba startup mount using that p file, whatever that rac modified parameter file, which has the rac parameters here with a cluster database equal to true. Start with that particular p file, and then create a sp file inside data test db, and then sp file test db.ora using that rac modified parameter file here. And then do shutdown immediate. You're going to shut it down your test db here. And then once the parameter files are created, you're going to create a init file, init test db.1 vora, which is pointing to your sp file, which is inside your data disk group. And then cat init test db.1 vora, which is pointing to data test db sp file test db.ora, which is inside your data disk group. And then copy that init test db or 1.ora file into your node 2 as a init test db2.ora, and then log into that node 2, and then go inside your Oracle home DBS location, cat that init test db2.ora, and then which will be like pointing to sp file, which is inside your disk group. And then come back to your node 1, set the environment to test db1, and then SQL, you do startup mount. Your database will be started and mounted. Do show parameter sp file. It will show that your database is started with the sp file, which is inside data disk group. And then do shut immediate. And then after you shut immediate, you do add this database to cluster resource. src add database test db, your Oracle home, your parameter file, shutdown immediate, and then data and record. This is a format to add your database to clusterware. And then add the instances, add instance 1, add instance 2, and then src config database. You can see your db unique name, your db name, which is pointing to test db, your Oracle home, your sp file, and your database role is primary, and your disk groups are data and record, and your instances are test db1 test db2 running under node 1 and node 2. And then that's pretty much your database is configured here. You can do src status database test db1 and test db2, which is not running on node 1 and node 2. You can do src start database test db, which will be get started here. src status database. You can see test db1 test db2 running under node 1, running under node 2. That's a pretty much post step for your RMAN duplicate database. And then your both rack to rack database is cloned successfully using your restore recover method and using your RMAN clone method. So we have a separate uh, sessions, which are separate demo classes, which are taken for your RMAN restore and recover and RMAN duplicate databases for standalone or for rack databases in my previous session. So if you missed out them, you can go ahead and then refer them always anytime. And then this is a quick intro about comparison between your RAC database restore and recover versus our RMAN clone. So this particular, if I share it one more time, probably this particular this logs and run logs or everything is uploaded to my blog, I believe. Probably if you need any run logs and whatever the content, rack to rack database restore versus RMAN clone. So whatever I explained so far, all the content, output and log file, everything is mentioned over here, all the step by steps. So you can go ahead and then refer this particular blog, and then you can get the command and you can do practice on that. Right, so that's pretty much what I wanted to cover on this particular today's session. If you have any queries and concerns or questions, you can ask in this particular video session in the comment section. So I'll try to answer that. Until we'll meet again in our next session. Until then, take care, guys. Thank you. Bye bye.